CReDo, the Climate Resilience Demonstrator, is a climate change adaptation digital twin. The digital twin combines a description of assets from the energy, water and telecoms networks with data from flood simulations to resolve the effects of flooding on individual assets and the corresponding cascade of effects across the combined network. The data in the digital twin are accessed as a knowledge graph. The knowledge graph uses ontologies to represent the assets, their operational state, and the relationships between them. The ontologies are hierarchical. Core concepts are defined separately from specializations of concepts that are specific to each network. This approach is extensible and is fundamental to achieving interoperability between data from the different networks. The design of the digital twin supports a distributed architecture that can combine data hosted by different providers. The structure of the knowledge graph is exploited to cascade information through only the parts of the graph that are affected by a given scenario. The computational efficiency of this approach will become increasingly important as the coverage of the digital twin grows. This example considers a 1 in 100-year storm under worst-case climate projections for the year 2070. The depth of flooding caused by the storm is shown in these blue patches. Assets that experience problems due to the storm are highlighted with red rings. An asset can be selected to view details about it and investigate the cause of failure. In this case, the power state is reported as false, meaning that the asset is out of service. However, the water depth is negligible, so the asset itself is not flooded. To determine the cause of the failure, we can investigate the dependencies of the asset. Here we see that the asset can receive power from one of two primary substations. Despite the apparent resilience in the network, we can see that both primary substations have been knocked offline by deep floodwater. The failure of these substations cascades to their dependencies, resulting in further failures across the network. Returning to the original asset, we can see that it supplies power to two sewage sites and a telephone exchange, both of which also lose power under this scenario. This demonstrates the ability of connected digital twins to assess the effect of different scenarios on individual assets and describe the cascade of failures across the combined heterogeneous infrastructure network. In the future, such digital twins could pull data from other sources, including live streams of data, improving their ability to represent the real world, allowing for more effective decision support across multiple sectors. CReDo illustrates what can be achieved by sharing data across sectors and demonstrates how connected digital twins might be used to support better decision-making.